Okay, this is Unit 4, video number 8, Redox. So we're going to look at the exchange of electrons in practice. So I've got a reaction up here. We take solid copper and drop it into nitric acid. We'll make copper nitrate, we'll get some nitrogen monoxide gas, and obviously make some water. So I want to determine the exchange of electrons here. Solid copper, we get an element in its standard state, an element without a charge. If we have an element and it's supposed to have a charge, we have to show that charge. So that's going to be 0. Nitric acid, the hydrogen here is +1. The oxygen is -2. The nitrogen is going to be unknown. An element like that bonded with oxygen is not going to take its normal negative charge. So let's write out HNO3 and determine the oxidation state on the on the nitrogen. So we've got one hydrogen at +1 charge, +1 nitrogen, unknown charge, +3 oxygens at -2, all equal 0. So 1 and -6 is -5, so x minus 5 equals 0. Bring the 5 over, x equals +5. So our nitrogen here is +5. Get over here, we have copper 2 nitrate. Okay, the charge on the copper is +2. The nitrogen here in nitrate is going to be the same as over here. It's +5, oxygen's -2. Here in nitrogen monoxide, don't use coefficients to determine oxidation states. Oxygen here is -2. There's only one of them, so one nitrogen must be +2. Get over here, hydrogen in water is +1, oxygen is -2. So now we can determine our redox. Copper, going to copper +2. Starting at 0, moving to +2, that's the loss of 2 electrons. But how many copper atoms are doing this? 3. So effectively we're going from 0 to +6. That's the loss of 6 electrons. So we lost 6 electrons there. Nitrogen's going from +5 to +5. That's no change, but also some of the nitrogens are going to +2. +5 to +2 is a gain of electrons. Okay, we're reducing our charge, so that's a reduction. But only 2 of the nitrogens are doing that. Each of those are gaining 3 electrons. 2 times 3 is 6, and we have the gain of 6 electrons. Okay? Anything that can cause something else to gain electrons is called a reducer or a reducing agent. So our copper here is what we call a reducer or a reducing agent, because it itself is being oxidized, so it is the compound causing the reduction. Nitric acid here, it is the compound causing the oxidation, so it is the oxidizer or the oxidizing agent.